Okay, so I'm just playing with it. Right, okay, let's have a look. Now, have a look at this here. Right, add the proper constant to each binomial, all right, so that the resulting trinomial, you know, you're going to have three terms, what I'm going to put here, is a perfect square trinomial. It says, then factor the trinomial, okay? Okay, so basically what this is called is, and if you look in your books, your notes, this is called completing the square. In fact, notice down here, where's my pen gone? Look at that, okay? It's called completing the square. So, add a number, add a constant to each term here, this binomial, so that the resulting trinomial is a perfect square trinomial. Okay, what does it mean? Well, let's have a look, okay? Got another page up here. Right, I'll quickly show you. Okay, right, here's what you do. I need to know what to add to this, okay? Right, and this is how it works. You take half of this and square it. What's half of 6? It's 3. What's 3 squared? It's 9. That is the number that goes at the end. Because watch, when you factor that, what's two numbers, remember you're factoring, what's two numbers that make 9 when you multiply, that make 6 when you add? That's 3 and 3, right? So in other words, if I were to factor, and that's what the question's saying, you know, factor it, I'd have this. And you realise what it means by the perfect square trinomial is, that's what it is, you can turn it into an x plus 3 squared. So everything that you do now to complete the square will end up as a single parenthesis squared. And if you go back and look at the questions we just did in the previous video, okay, they all had these like parentheses squared, so we had to square root both sides. So you're aiming to you're kind of building up some techniques so you can solve some more complicated problems. Okay, so have a look at this one. 18. What's half of 18? It's 9. What's 9 squared? It's 81. If you were to factor that, it would be x plus 9 with another x plus 9. In other words, it is x plus 9 all squared. Now, look, the little shortcut for this is this. Look, if you realise that half of this is 3, that's the number that's in the parentheses. What's half of 18? It's 9. That's the number in the parentheses. So can you see that? Now, if I was to do a shortcut on this, well, I know that half of 10, even though it's 10 or negative 10, when you square it, half of 10 or negative 10 is 5 or negative 5, but when you square it, you will get 25. Notice the number on the end is always a positive answer. It's always a positive constant at the end, all right? Because whenever you square something, it's positive. But the shortcut for this, I'm going to write all this here. Yeah, I know it's going to be x minus, because it's a minus, what's half of 10? It's 5. And of course, this is all the thing that's squared. So it looks like these here. Okay? And that's it. So that is you. You've just completed the squared. You've formed a perfect square trinomial, which is this thing. And you factored it. I'll just do anything else. Okay? Give me even numbers for now. Okay? X squared. I don't know. Minus 16x. If I need to add the number on the end, what's half of 16? It's 8. When I square it, I get 64. But this will become an x. I know it's a minus, because that's a minus. I know it's 8, because that's what half of 16 is. And it's all of that squared. And you try it. 8 minus 8 squared, x minus 8, sorry, times x minus 8 is x squared minus 16x plus 64. So look for patterns, look for shortcuts, okay? In fact, if I actually go back to the actual question on this paper here, I know that's going to be, what's half of 8? I've already done an 18 one, but half of 18 is 9. When I square it, that's 81. Okay, but the answer is going to be x. What's half of this negative 18? It's negative 9. All of it squared. Okay, and that's what you do. Okay, so that's you completing the square.